Determine algebraically whether these functions are inverses of each other. So algebraically, again, this is going to be this is the idea. If we switch x and y, and we solve for y, do the equations match up? If they match up perfectly, we'll know they're inverses of each other. If they don't match up, if they're different equations, we will know that they are not inverses. So for part I, we have y equals 3x minus 6. If I want to find the inverse of this, I'm going to switch x and y and write x equals 3y minus 6. I then can get y by itself by adding 6 to both sides and then finally dividing by 3. And I get y equals x plus 6 divided by 3. Does that match perfectly? No. Well, sometimes things don't match, but you could still maybe do some math. Is there anything I'm allowed to do that says you are just allowed to change a plus sign to a minus sign? Can you do that mathematically? Just decide I want to change it to a minus sign? When am I allowed to do that? Yeah, I'm not allowed to do that. So it doesn't match. This means they are not inverses. Okay? Split my page in half. You can go underneath. For the second one. What do we have at the beginning? Something that you probably haven't seen much before. It gives an equation, then it has a comma, and then it writes this. What does this mean? This highlighted part is a restricted domain. We only have half the parabola. Normally, can you see that this would be a parabola flipped vertically and then shifted up 3? And then, with that parabola, we are only taking the right-hand side of it, not the left-hand side. So we're only taking half of it. If we do the inverse, we'll probably get a square root. Do we get the right square root here, or should we have the one with the minus sign? That's our question. So if I start with the same idea where I switch x and y. So here, I can just put an arrow over here and an arrow over here so I don't have to rewrite it. Personally, what I would do here, because I want to get the y by itself, I'd probably add the y squared to this side and move the x to this side, 3 minus x. And then when I get y by itself, I would have the plus or minus okay? Now, everything switches. So not only does the equation all switch, but the restriction on the domain becomes a restriction. I'll just write this in blue. On our range. So if our domain is restricted to be x bigger than 0, our range of our inverse has to be restricted to be y bigger than 0. Which one gives you things that are bigger than 0? Positive square roots or negative square roots? Positive square roots. Because if you had the negative square roots, all of your answers would be negative. And all of our answers have to be positive I'm just gonna write the plus to really make it obvious that that's what I chose. Does it match? Yes. So part B are inverses. Mm-hmm.
Okay, so if the parabola is negative, then it's upside down, right? And then you're taking the part where it's greater than or equals to 0.
Mm-hmm.
Right? So your parent graph is just
If I took my parent graph of x squared, I flipped it down and then shifted it up 3, I would get this.
yeah.
Okay?
And
But
then
we are only taking
that part.
this part.
Okay. And then the inverse will be that. And then the original graph for that one is like that, right?
Mm-hmm.
Then you because there's a negative
This, the way this is written is a little confusing for graphing, right? Because we normally write the x first. So if you wanted to graph this, which I think you're talking about, if I was wanting to graph that, I would first write it with the x first. Would you agree that 3 minus x is the same as negative x plus 3? Okay? And then you can see your horizontal reflection and your horizontal translation. But careful, it's not in factored form.
Hi, sorry to interrupt. Can I have Wen to the office at the bell, please?
Yeah.
Thank you.
So I would have to factor out that negative. So it would, that graph, that square root graph, take your regular square root graph, would have a horizontal reflection and then be moved 3 to the right, which makes sense if you think you had your original point at 0, 3. When I switch it, I should have 3, 0. And instead of 1, 2, I would have 2, 1, and that would be
the graph for that one.
the graph for that one. This purple graph is this graph right here. A little hard to see when it's 3 minus x just because it's not in the order that we've been learning our transformations. But feel free to rearrange the order so that it looks like
Wait, but we have a reflection. Yeah, you're meant to choose the vertical reflection, right?
so this final graph, because it's a perfect inverse, is reflected over the line y equals x.
No one thing.
What you're saying is this negative is a reflection. Yes, because your original square root looks like this, right?
Mm-hmm.
And then it got reflected this way.
Yeah.
And then it got moved 3 to the right.
Oh, okay. Okay. Okay, so the negative was outside, and it's going to get reflected over the line. Y equals to 0.
It's going to get reflected over, it's going to be a horizontal reflection. That's a reflection over x equals 0. Gets reflected over your y.
If the x was outside.
If the negative was outside, that would be a different reflection.
Okay.
Mm-hmm. Yeah, so when deciding between these two, that negative outside would have flipped it down, and ours doesn't flip down.
Mm-hmm.
Lots of things to think about. I find that some of these questions are a little challenging. We did the graph part for B to verify that it was an inverse. I'm going to skip the graph part in A. You could graph this as a straight line, y equals mx plus b. You could also graph this as a straight line, y equals mx plus b, but you would have to rearrange this and write it, divide everything by 3, so you get 1/3 x minus 2. And when you look at both of those graphs, the x's and y's aren't switched. It doesn't match up right. It's not a reflection over the line y equals x. So from the graphs, you could see that it doesn't work. If you want to see the graphs of those, I probably have done it on a previous video, but we'll save ourselves a little bit of time. Questions for this one? Okay, I have 7, 8, 11, and 13, and I put stars at 11 and 13 because they'll make you do some problem-solving stuff. So if you want practice with problem-solving questions, make sure you take a look at those, and then when you get stuck, make sure you come in and ask questions for help, and I can help you with that problem-solving as we're going.